by? Secant x minus 1. Secant x minus 1. What are we going to multiply the other one by? There you go, secant x plus 1. Now we're catching on. Right? So this gives me one giant numerator of secant x plus 1 plus secant x minus 1. What's on the bottom?
It'll be secant squared x.
Yeah? No. If you FOIL them together, you just get the secant squared x minus 1. All we did was FOIL one of them. Okay, we just took one of these and FOILed it since it's the same for both of them. It's a difference of perfect squares, and those are conjugate factors, so that's why the middle term is gone. What do you see in the numerator? What do you see in the numerator? Wait. We're adding these two things together, not multiplying. If we add them together, how many secant x's do we have? 2 of them, right? It isn't funny. Yeah, I don't really think that was funny. I like the fact that people try. If you try and fail, that is, in my book, 100% better than not trying. I love it when you try, even if it doesn't go the right way, because you're thinking. What do you got in that numerator besides? Is that it? Is that the only thing in the numerator? Yeah, because these cancel, don't they? No, that's not going to help you because you need to combine your numerators together. If you're adding 2 fractions, you must be able to combine them. All right, now, instead of putting secant squared x minus 1, what should we put in its place? Go look in your notes if you can't think of it. Something to do with this Pythagorean identity. No, the derived ones? No, that's why I said you need to know how to derive them. I mean, for instance, if you need secant squared, what are you going to do to this one over here? What are you going to divide it by? Your only 2 choices are cosine squared or sine squared. If you want a secant squared, what are you going to divide it by? You're going to divide by cosine squared. Well, if you do it to that one, you've got to do it to this one, right? And you got to do it to the next one. So that gives me 1 plus tangent squared equals secant squared. So what is secant squared minus 1? Tangent squared, isn't it? Now, I'm hoping that the answer to this question is sitting right here. Now, why do you think at this moment I think the answer is the one on the left? Does it? Well, there's going to be some stuff that cancels out here or simplifies, but what is screaming at me that the one on the left is going to be the one we're going for? There's a 2 in there. Okay, and there ain't no 2 in the second one. All right, so that's my clue right now, folks. That I'm going for the one on the left. All right, so let's see here. Instead of writing it vertically, let's write it horizontally and see what happens. 2 secant x, that would be what? 2 times 1 over what? Come on, secant. 1 over cosine x times, now think about this. If this was sine squared over cosine squared, and we were doing that whole keep, change, flip idea, what is it going to be multiplied by? Cosine squared, sine squared. Anything cancel out? We can get rid of how many of the cosines? One of them. Okay, now focus your attention up there on what we said the answer was and see if we can kind of piece this together. We obviously have the 2 in the front, right? How do we get cotangent? What do we need for cotangent? We need a cosine from the top and a sine from the bottom, right? And according to this, we've got 1 cosine there, and we've got sine squared in the bottom. So I'm going to do that little mitosis thing, right? I'm kind of pulling it apart. Okay, sine squared, I pulled, you can see I have, in the bottom there, I've got sine x in one and sine x in the other, but they're both in the denominator, so I just pulled them apart a little bit. So, what is this one? Cotangent. And 1 over sine is? Cosecant. Yep. Ding, 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 we've got our answer. That is awesome right there.
Where did you get cosine square x over sine square x?
Okay, so we had right here, lock it in place, sorry. Right here we had tangent squared. We were dividing by tangent squared. Now we know that tangent squared is sine squared over cosine squared. But when we decided to change it from division to multiplication, we flipped it, right? So it was kind of like I was substituting and flipping at the same time. Okay? Kind of like Robin from Lego Batman. Yeah. Oh, you got it. It's a great movie.
There's Rock Hudson in it.
Where in the world does this stuff come from? I mean, my mind is weird too. I don't know where some of the stuff comes from in my mind, but it's a whole new world, man. It's like I get lost, Favorite superhero? I don't know. I'm going to think about that one. Let's get through example 4 here. This is our last example, and then we could try to do some homework, practice problems together. Okay, setting up a difference of squares. Actually, I probably need to check some homework. Woo. Okay, now, remember, this is not the idea of cross multiplication, right? I know what you're getting at. You've seen proportions all your life, and you've been programmed to do that. I am trying to go from the left side to the right side. Cosine t over 1 minus sine t. Okay, now, when I look across at the right-hand side, I get a clue as to what I should probably be doing. I'm going to multiply top and bottom by 1 plus sine t. Now, why was that my hint? Because look, in the numerator on the other side is a 1 plus sine t. So when we get done with this, we better have a 1 plus sine t in the numerator of our answer. So I'm using the right side to kind of guide me. So I will leave the numerator alone for the meantime, and then what do you get in the denominator when you multiply that stuff together? Come on, foil it together. Tell me what you get. Nope. Come on, foil. First, outsides, insides, lasts. There is a sine t squared in it somewhere. One minus sine t squared. Sorry, that was a bad looking minus sign. 1 minus sine t squared. Okay, so no, we're not. There wasn't a 9 anywhere in the problem. Okay, now look here and see if you recognize what you see in the denominator and what you think you should replace it with. Don't cross out anything from the top yet. What did you replace with this within the bottom? You said it. Say it louder. Cosine squared. Are we seeing anything that might cancel from the top and the bottom? Okay, nice to meet you. What's your question? This is the Pythagorean identity, right? Sine squared plus cosine squared equals 1. You remember I told you all these identities were going to be super duper important, and if you didn't know them, it was really going to hurt? Yes. And you know what? I know you can look stuff up on a formula sheet. But to get the speed you need to go through these questions on quizzes and tests, you're going to need to know some of the basic ones at least. I mean, I know there's a lot to memorize, so I'm not asking you to memorize a bunch. So, look back, remember, the right side is supposed to give me a clue as to how to do this problem? I'm supposed to get a cosine in the bottom when I'm done. Is that going to happen? Yep. Yeah, because one of the cosines cancels out. Ding, 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 we got it. Cosine t, that's cute. It looks like cost. Yes, 1 plus cent over the cost. All right. Yes. 47. Write each expression as an algebraic. Okay, so we got 1 minus sine squared x over 1 plus sine x. Now this is just simplifying. What can you break or factor the numerator up into? Yes. Yes. 1 minus sine x, 1 plus sine x. Sorry, my sine x ran out of its own parenthesis. I wonder if I can erase that quickly. And new parentheses. Anything cancel out? 1 plus sine x, and there's your answer, 1 minus sine x. Like, for instance, could I have substituted cosine squared in for this numerator right here? Could I have done that? Yes. Would it have helped me? Not at all. So, yeah, I could have done that, but it wouldn't have helped me. All right? Does that make sense? All right, how about, you said 49? All right, so sine squared x. Now, what is my clue in the denominator of what I should do in the numerator? What's the clue in the denominator of what I should be doing in the numerator? What am I going to change that numerator into? 1 minus cosine squared. My clue was sitting in the denominator. Why is that so useful to me? Don't you slash those ones. Right? We've got addition and subtraction up there. We can't be just slashing. Oh, you know, if that's going to happen, guess what else is going to happen? COSX1. So we got negative squared over plus. Okay? Please don't do that to me. Factor the numerator. Please. Factor the numerator. Yes. 1 minus cosine x. 1 plus cosine x. Now what?
Then you take out the 1 plus.
So there's your answer.
Always be something that'll cancel out when your denominator.
When you're simplifying expressions, we are looking for substitutions which will make things disappear. We want to see things vanish. Not in a simplifying question. Now, if we were solving an equation like down in the 51 through 56 range you see down there, we could end up with something that's undefined, or that it would be a dead-end factor. Anything else? Yep. 51. Do you see a GCF that you can pull out of 51? Cosine x. And if you pull that out, you're left with 2 sine x minus 1. Now, if you've got it in factored form, what are you supposed to do? Set the factors equal to 0 while you go to lunch. If you've got, maybe I should draw a cool circle. Let's use the circle tool. Yes. Because I can, we can do that. Yes. Okay. So, he's not even paying attention. All right. Oh, that's horrible looking. So, from the one on the right, where do we have cosine being 0? At the top and at the bottom. What are those two values? Yes, definitely radians. Pi over 2 and 3 pi over 2. So those are two of those solutions. Over here, if we do our sine x and we solve for sine x, what do we get? Sine x equals? If we add 1 and divide by 2, we should get positive 1/2. If we think about 1/2, and that's a y value, wow. It's like some sort of ninja. It's like a Mutant Ninja Turtles. Okay. What are these two angle measurements where the y value is 1/2? Pi over 6 and 5 pi over 6. So there were 4 answers to this question. Yes, question. I can't. That one's not too hard. You take the square root on both sides. Right? Oops, sorry. There's a 3. We take the square root on both sides. We get tan x equals what? Tan x equals what? Radical 3 would be half, right? Plus or minus, thank you very much. Now, I'll try to draw with a different color. Here, with green on my circle down here. The square root of 3, the slope for that one looks like about that right there in the green down there on my circle. What are those two angle measurements? Pi over 3 and 4 pi over 3. Okay? And then, for negative radical 3, right? What are those two solutions? 2 pi over 3 and 5 pi over 3. So that's the remaining solutions of question 55. And we should call that a wrap. Instead of a sandwich.